Hello everyone, welcome to Rubber Industry NewsHour. We are on episode number 13. Namaste, Sawadee Krap. Welcome to this special episode on the weekly program for the rubber industry NewsHour. As you know, this is program happens on every Monday. Welcome you all for this program today. Before I start, give you more details on what is in there today, let's have a quick look about the what kind of information will be included in the Rubber Industry NewsHour. Let me show you a short video to understand about the Rubber Industry NewsHour. That's about the Rubber Industry NewsHour. I'm hoping that you get an idea what it is all about. But you don't see all the things in one episode. We will cover various things in each episode, not covering everything. The content will be divided into the various episodes. As you know, this program, Rubber Industry NewsHour, is owned and managed by Technobiz. I think many of you know about Technobiz, what we are, what kind of services we offer. For the benefit of the persons who don't have much knowledge about the Technobiz, let me show you a short presentation on the Technobiz so that you have an better idea about the Technobiz. Okay, that's about the Technobiz. I'm hoping that you have a better idea now. What is Technobiz? What kind of services we offer? Okay, let's get to the today's session, the Rubber Industry News Hour. We are on episode number 13. Let me give you what are the main highlights today in this episode. First, we will have the natural rubber market review by Mr. John Jacob. He's a rubber industry analyst. After that, we'll have the panel discussion on the cost reduction in molded rubber products manufacturing. We have 4 experienced rubber industry professionals with a huge experience. They're going to discuss about what are the opportunities on the cost reduction in the molded rubber products manufacturing. And also we have a brief advertisement issues like a rubber industry business profile, rubber industry buyer guide, and also we have a short presentation on the upcoming rubber industry events, and also introducing the various educational programs for the rubber industries available. So this is basically the overview about the in episode number 13 today. Just give you some update. This is a new notification. So far, you have joined this news server for free, and from episode number 15 onwards, this is available for the subscribers only. But you can subscribe for free if you join the next episode, okay, or you join previous episodes as well. And if you register for the episode number 14, and you have to make sure that you join the live session so that your 1-year subscription will be activated. Basically, we have lots of people are subscribing, viewing our this program, like to engage with all the subscribers appropriately so that this rubber industry news server program is more useful, more productive for the benefit of the rubber industry. So it will be subscribers only from episode number 15 onwards. But subscription is free. You can join next episode and you automatically get 1-year subscription for free. If you don't join the next episode, you may need to pay for the subscription. That's how it is. So I hope you understand this about the subscription issues. Okay? And you can see past episodes of the Rubber Industry News Hour in YouTube channel, the Technobiz. Okay, so you can check it out, our Technobiz channel, and you can find all the past episodes as well. Okay, let's get to the session. Rubber Industry Market Review. Under this session, Rubber Industry Market Review, we're focusing on the natural rubber market review by Mr. John Jacob. Let me brief you about the Mr. John Jacob. He has been in the rubber industry more than 30 years. And is recognized as a global rubber industry analyst with extensive experience in analyzing the rubber markets, forecasting industry trends, and also formulating long-term policies and development plans for natural rubber sector. He served the Association of Natural Rubber Producing Countries, we shortly call ANRPC, at Kuala Lumpur, as its a senior economist for 11 years. Before that, he worked for the Rubber Board of India in various positions for 23 years. So Mr. John Jacob is an internationally recognized independent analyst in the rubber market, not particularly the natural rubber market. So let's invite Mr. John.
Hi all, welcome to Natural Rubber Market Review. Before we review the prices during the previous week, let us recall what were the observations we made last week about the short-term outlook. We made some specific observations regarding the short-term outlook. Number one, we observed that prices will move sideways in the short term. That means there is no major uptrends or major downtrends. It will be moving around the central line. That was an observation. And we had specific observation regarding RSS3 futures traded on the Osaka exchange. We observed that because of the yen's major devaluation, is continuing devaluation, yen-dominated Shanghai Osaka rubber futures will be more attractive, and the cheaper yen will attract more investors. So RSS3 futures traded on the Osaka would be gaining more compared to rubber futures traded on other exchanges. And we observed that RSS3 prices, physical markets, in the physical market Bangkok, RSS3 prices would be performing better compared to other forms of NR in various other physical market, because RSS3 has a RSS, not only 3 RSS has a niche market, and because of the seasonal low supply, the market arrival of RSS is low, and that will be giving positive influence on RSS3 physical prices. Again, we made an observation regarding the Indian market. In India, around 70% of the produce is processed in the form of RSS, which is in sharp contrast with the other major producing countries where TSR is a major traded form of natural rubber. We observed that in India, around 80% of the rubber is produced in the state of Kerala, and Kerala, the summer rains have started. So means normally farmers will resume tapping once they get 2 or 3 very good rains. So we made an observation that farmers will be resuming tapping in India, I mean in Kerala, because Kerala is contributing 80% of the rubber produced in the country. And because of the improved supply, the Indian domestic market in India will be slightly down. That were the observations we made. So keeping that in mind, let us review the prices. We have 6 charts here. Let us start with the Shanghai rubber futures traded on the Shanghai markets. Chart number 1. So this chart shows the trends in the rubber futures contract traded on the Shanghai exchange from 21 March until 8th of April. That means the last 3 weeks prices are graphed here. So the last part, that is a week ended 8 April. When we look at the last part, week ended 8 April, prices average at 13,668 yuan, which is 1.2% higher compared to a week before. Means last week prices averaged 1.2% higher compared to a week before. Not only that, we can see the price went up and then drastically coming down. That was from the graph we can see towards the end, the price went up then coming down. The price was going up, but price was going up, seeing the positive, expecting some improvement in the Russia-Ukraine war peace talk, but price went down because of the strict lockdown imposed in the Shanghai city for 9 days, effective from the end of March. Not only that, after that, authorities decided to extend the period of lockdown. So that means in the Shanghai markets, sentiments have been dominated by the 2-tier lockdown imposed in the Shanghai city. So that particular the lockdown has been actually the market sentiment has been dominated by the lockdown. This is a story about the Shanghai rubber futures. Means 1.2%, still 1.2% higher. Then we go into the psycho markets, chart number 2. The TSR20 is the most popular grade of natural rubber traded on the psycho market, Singapore exchange. So the graph here shows the trends in the rubber futures from 21 March until 8th of April. So let us focus on the last week, that is the week ended 8th of April. The rubber futures traded on the psycho market averaged $175.6, roughly $176 per 100 kilogram, which is 0.8% higher compared to a week before. Here also we can see a reflection of the price trend in the Shanghai market. Price was going up but because price was going up, but in the first week of April, expecting some kind of improvement or hope of some kind of ceasefire in the Russia-Ukraine war, but there was no further development. At the same time, the Shanghai city lockdown impacted the market sentiment. Shanghai market lockdown is very important for rubber because China is consuming around 45% of the, accounting around 45% of the global demand for natural rubber. So that means that Shanghai is the commercial capital or economic capital of China. So whatever happening in Shanghai is crucial for rubber markets. Now we go into the chart number 3, which is showing the trends in daily prices, daily settlement prices of RSS3 futures traded on Japan Osaka Exchange. So the graph shows the trends from 21 March until 8th of April. So here, in the last week, that means the week ended 8th of April, RSS3 futures averaged 266.21 yen per kilogram. This is 3.6% higher compared to a week before. That means the increase in the case of RSS3 futures traded on the Osaka Market Exchange is much higher compared to the rubber futures traded on Shanghai or Saiko. As I mentioned at the beginning, and what we expected a week before, the yen has is devaluating. Yen has sharply devaluated over the last 2-3 weeks. In fact, yen has hit a 6-year low during last week. Means the yen's strength against the dollar hit a 6-year low during last week. So when yen is weak, yen denominated assets, I mean in the case here, RSS3 futures are traded in terms of yen. When yen is weak, yen denominated assets are more attractive to speculative investors. So that means that because of the weak yen, investors were attracted to RSS3 futures, and that helped the prices to go up with a greater momentum compared to other futures exchange. At the same time, we have to take into account that the physical market of RSS3 in Bangkok was also, there was some kind of positive development because supply was short, and already there's a demand. RSS has a niche demands, and there is demand, but supply was not adequate to meet the demand. So that physical market also supported the RSS3 futures traded on the Osaka Exchange. So these were the trends in the futures market. Now let us go into physical markets. We have chart number 4, which is showing the prices of STR20 in Bangkok physical market, and also SMR20 in Kuala Lumpur physical market. Both the prices are in terms in FOB. And as I earlier mentioned, around 70% of the global trade in natural rubber is done in the form of TSR. And STR20 and SMR20 are popular grades of TSR. They are trade names of TSR. STR20 with reference to Thailand, and SMR20 with reference to Kuala Lumpur. So we have the physical price trends right from 21 March until 8th of April. So in fact, we can see that the physical price also reflected what had happened in the Shanghai market. So price was going up in the first week of April, but in the second week of April, the price started moving down. That means the physical prices reflected the trends prevailed in the futures market. So in the week ended 8th of April, SDR20 in FOB Bangkok averaged $176.2, which is 1.1% higher compared to a week before. And SMR20 Kuala Lumpur averaged 176.3, which is also 1.5% higher compared to a week before. What is important here is that both Bangkok and Kuala Lumpur market prices were more or less similar, more or less same, $176 per 100 kilogram, almost same. And also we had to take into account that the TSR20 traded on the SICOM exchange also was around 176. That means both the physical market prices were almost same. Not only that, in the futures market also prices was ruling at that same level compared to the physical market. Now we go into chart number 5, which is showing the price of RSS at Bangkok and RSS at Kottayam. So at Bangkok, the price referred to FOB price of RSS3, and for Kottayam, the price refers to RSS4 at local market. Local market means it is not including taxes, others or other charges. It is a local market price. So what the blue line shows the Bangkok price, and the orange line shows the Kottayam market price. So last week we made very specific observation regarding the RSS price. One observation we made was that RSS price at Bangkok, we expected that price to perform better compared to TSR and latex, and that happened. Bangkok average RSS price averaged $242.3, which is 5.2% higher compared to a week before. 5.2% in 1 week means it is substantial. But at the same time, we made an observation regarding the Kottayam market, as I mentioned before, Kottayam or in Kerala, because the farmers are expected to resume tapping after the wintering off season, because rubber growing regions in the Kerala state of India received very good rains, and the farmers are expected to resume tapping. And because of the improved supply, we expected the prices to be lower in India. As we expected, Indian price or Kottayam local market price of RSS4 averaged $229.3 per 100 kilogram, which is marginally lower, 0.2% lower compared to a week before. So the prices, RSS prices both in Bangkok and Kottayam moved in the way we expected. Now we go to chart number 6, which is comparing the latex prices. We have two important market for latex. One is Bangkok market and the other is Kuala Lumpur market. So the graph here shows the price trends right from 21 March until 8th of April. Let us focus on the last week, the last part of the graph. That means the week ended 8th of April. Kuala Lumpur market averaged $163 per 100 kilogram, which is 1.1% higher compared to a week before. And Bangkok market averaged $160.8 per 100 kilogram, which is 1.2% higher compared to a week before. So summarizing all the markets, suppose we summarize what we have seen from all the charts. What we can see that in the case of RSS, Bangkok market performed with a higher momentum. That is one important observation. This was what we expected. And RSS market in India came down marginally came down because of the improved supply. This is only different. But when we look into TSR grade, technically specified grade, which is constituting around 70% of the global trade natural rubber, and also in the case of latex, which is representing around 10% of the global trade in natural rubber, means 70% is TSR, around 10% is 10 to 12% is latex. Means in those for those two grades, prices increased by roughly speaking around 1% during last week compared to a week before. So this is a story of how prices performed last week. Now let us examine how the prices are going to perform in the coming week. What are the important factors? When we look overall, supply is expected to remain low globally with the variation across countries, because in the case of India, supply is going to improve because farmers are resuming tapping. Because some of the farmers will resume tapping only after Easter. Easter is coming Sunday. So some of the farmers will be resuming tapping only after Easter. So after Easter, we can expects further improvement in supply in the case of India. So that will have some kind of a negative influence on the Indian market. That is a special case. But in all other markets, the physical market, we are expecting supply to remain low because it may take some more time for the farmers to resume tapping. But at the same time, in some of the countries, farmers are in the process of resuming tapping. So that means there will be gradual improvement in supply. But next week we are not expecting a major improvement in supply in the global perspective. That is one thing. And looking into the demand side, demand actually the outlook on demand expectations have been weighed down largely due to the Russia-Ukraine war and the economic sanctions announced on Russia. So this is a major factor weighing down the demand outlook for natural rubber. So this is impacting rubber demand in various ways. So I'm not going into details. We have to consider what is going to the supply chain, global supply chain, logistic and shipping costs. We have to consider what is going to happen with reference to the problem of the chip semiconductor shortage. So all these problems have been aggravated due to the war and the economic sanction. And Russia and Ukraine are prime sources, means major sources of specific metals which are very important in chip semiconductor shortage manufacturing, and also which are very important in the case of automobile industry. So that means they'll be having major negative influence that will continue. So next week, what is going to happen in the Ukraine-Russia war? If there is any positive development, some kind of a ceasefire or some peace talk going to succeed, that will be having a major positive impact on the prices. That is one thing we have to consider coming to the next week. If there is any positive development, that will be reflecting on the prices. The next important point is, as I mentioned before, around 45% of the global demand for natural rubber is coming from China. And in China, the commercial capital or economic hub of the country's economic activities is Shanghai. Shanghai city is remaining closed. Means manufacturing activities have been hindered by the strict lockdown. So this is a situation as of now. So we are expecting some kind of demand slowing in the case of China, mainly in the case of China. So next week we are not expecting a major uptrend in price, and we are not expecting a major downtrend in price also. So this is what we are expecting. That is outlook for the next week. And with that, I am concluding here. See you next week at the same time. Thank you very much.
Okay, that's the natural rubber market review by Mr. Joe Jacob. Now we have a short commercial section of this rubber industry news hour. First, introduce about rubber industry business profile. In this section, we introduce the company and their products and services. Let me introduce the company here. Technovaxcom or Russia Chemical, shortly for TWC Group. And this is basically recognized as the one-stop outlet for specialty rubber chemicals. Let me show you the presentation on the TWC Group. Okay, that's a presentation about the TWC group, shortly the Technovax Chem, Rasha Chemicals. If you are interested in their service and products, please do reach out to them. Now we have the rubber industry buyer guide. This is also a commercial session of the rubber industry news hour. In this one, we introduce various companies in a very brief way. Let's have a look at the rubber industry buyer guide. Okay, that's about the rubber industry buyer guide. If you're interested in any of these companies' products and services, please do reach out to them. I would like to introduce our upcoming events for the rubber industry. I think many of you know about IRC 2022. It's an International Rubber Conference and Exhibition, which is going to happen on the 24th and 26th November in Bangalore, India. Now let's look at the short presentation on the IRC 2022. Okay, that's a presentation of the ARC 2022. I welcome you all to participate in this unique event in Bangalore in India during the 24th to 26th November, organized by the Indian Rubber Institute. Okay, we are into the main part of this today's rubber industry news hour, rubber industry panel discussion. Today's panel discussion is very unique, very important. It's focusing on the cost reduction in molded rubber products manufacturing. We have 4 distinguished experts in rubber technology, rubber processing. I'd like to invite one by one to come forward and introduce Mr. E. Palaninathan. Currently is a technical consultant. He has more than 35 years experience in the rubber industry, in compounding, processing, well experienced, and it's a pleasure to have Mr. EP. Shortly we call him EP, so I think everybody can call him EP as well. So welcome, Mr. EP. Now our next panelist is Dr. Hans Joachim Graf. He's also a consultant. He has a 50+ years experience. He worked in the rubber products, rubber processing, chemicals, machinery, 50+ years experience, huge experience. He's going to talk sharing his today's discussion on cost reduction in rubber processing and rubber products manufacturing. Now we have Mr. Devin Lokagarivar. He's currently the president of Maplan USA. He's been whole life, I think he's been working in the rubber machinery industry and worked with lots of clients, and he's one of the right persons to sharing his experience and views on how to reduce the cost in manufacturing of the rubber products. Mr. Devin, please come forward, open your webcam. Hi there, welcome.
Hi everybody.
We have Mr. R. Karthik. He is a manager of the Sheet Polymer Products. He owns a company. He produces rubber parts, and so he knows the pain of the cost compared to any others. And happy to have Mr. Karthik, and he will be looking at his 360 degrees views about the cost issues, how to reduce the cost, our opportunity size. Guys, welcome you all. If you don't mind, I request you all to, okay, I think Devin and Dr. Graf, can you change your webcam settings to widescreen, please? Go to the preferences. Preferences, please change your webcam settings, please. There is an option called, when you click on the preferences under webcam. Okay, give me take a minute. I would like to have a nice view of all when you guys are on the screen. That's good. Devin is fine. Yeah, thank you. Okay, yeah, perfect. All good. All good. Click OK, sir. You did not click OK. You need to click OK, Dr. Graf. Okay, look good. Look good. Okay, welcome you all. Thank you for accepting my invitation to talk about the important subject called cost reduction in molded rubber products manufacturing. I want to just put a rationale behind this cost. I think some of you talk about maybe, when talk about cost reduction, everybody is very, I think Karthik knows very well about cost issue because he's the one finally paying the bills for the chemicals manufacture, machinery guys or the energy utilities, you name it, the taxes, all kinds of, So this session is focusing on the 360-degree aspect. What are the opportunities available? Whether it is choosing the right machine, whether it's right material, or how you handle your materials, or whether energy aspects of it, or labor cost. Okay, what are the options are there to manage the labor cost, and you call we call it operational cost or OPEX and CAPEX. I've been discussing with Devin about these issues. So I have only one question, one talk focusing on the cost reduction. I have 4 experts here. I want to take their brains out and give us some ideas and what are the possibilities, what kind of opportunities are there for particularly for the rubber product manufacturers, where they can save the cost. If they are doing good practices, we talk about good practices. If they are doing bad practices, we highlight about the bad practices as well. So now I invite EP first to get started. EP, over to you, sir.
Good afternoon. It's nice. It's an opportunity that we have a panel to discuss on the cost, which is a very important aspect. Always, cost is not to be seen as a fear. Cost reduction. Let us talk about cost optimization. I think I use the word cost optimization for the molded rubber products. It's a very good. The cost is a very good business driver, which gives a lot of opportunity for the diversification of the industry as such. A lot of small scale and medium scale industry emerge out of the cost. So that way, cost reduction or cost optimization is a good thing which happens in the industry. Today, all automotive companies, they work for the frugal engineering. I hope all of you know the frugal engineering means manufacturing a product with the best performance, with the less complexity and a good and also the less cost. This is the approach which being currently focused on all automotive manufacturing. So when the automotive manufacturing focus on this, as a rubber product manufacturer, we also should focus on how to optimize the cost. So which is going to be a business driver. So as you all know, it has got a various component, like in the case of, it starts from the design process, in the inspection and testing, with some corrective actions and also some thumb rules and etc. etc. So in the design, if you go, there is always a mission. What kind of a mission we select, whether the mission is going to add value or it is cost effective. And when you go for a material, what kind of a material or compound or composition we are going to use. So let's come to the process. We have to identify are the processes more effective. And coming to the number of, especially in the molded rubber products, it always a question of selecting a compression molding, a transfer molding, or injection molding. This dilemma we have to win through and get into a correct machinery. Apart from that, when we come to the process, we also want to finalize what is the curing time. Is it a high temperature, high temperature and low curing time, or a low temperature, high curing time? All this technology plays into role. Along with this process parameters, we also encounter some devil like defects. So we have to come out of the defects or devil, which is also a major responsibility of the manufacturer, rubber product manufacturer especially. And in this process, they have to manage the labor cost. Today, they're getting the labor also a biggest issue. I hope Mr. Karthik will show more light on this. So when you manufacture a product, apart from the next stage goes in inspection and testing, because we are assuring a quality. Without a quality, nobody can survive in the industry today. So we have to ensure the outgoing quality is good. So the inspection became a necessity, especially in Indian industry. Unless otherwise, we have got an established SPC to produce very good CPK value in our manufacturing. Next is the testing. Even though the inspection testing is a bit of a non-value added operation, but it gives the assurance that the outgoing product is good. So it is essential as far as today's rubber industry is concerned. So some of the next aspect, some of the corrective and preventive actions, it should not unnecessarily increase the cost of the manufacturing. We would have planned a certain cost. During the process of doing some preventive and corrective action, we should not add excess process that should not complicate the whole thing. I hope Mr. Karthik will agree with me. Many of the companies, they do double inspection. It doesn't add any much value. We have to focus, as per our new QMS, we have to focus more on the process rather than the inspection. Karthik. So there are a lot of issues on which we can focus one by one. So with that, I will leave to the Dr. Graf to put on his views so that we will continue in the next cycle to discuss on the left out items.
Unmute yourself, sir. Unmute yourself.
So, okay, thank you very much for handing that over to me.
Yeah.
From my perspective, there are always two things in any process, and that is raw material cost and operational cost. And when we do that, we see normally a normal part production without any inserts, and a good injection molding process should be dominated by around 60% of the material cost, and remaining 40% should be including everything else, even the earning. So if we say so, then we know that material is a major part and process cost is a smaller part. And the sentence, if we work on either side, is that we say quality is a given. Yes, we do not discuss that, we just supply. Because otherwise we will have big trouble with the customer, specifically in the automotive industry and in other very sensitive or even more sensitive industries. And then you should know that we have special rules in Europe. I think in Germany started that somewhere, and that is the rules for safety parts. So if we now do something, for example, let's start with the process side and tune the process to get more output per hour, something like that. We say we need to have an in-depth understanding of the process to be able to do that. So we come to education of the team running the machine or running the process, and we come to an intimate knowledge of the process itself. And let me do something in parentheses. We have here high labor costs. So that means we dilute the cost if we increase parts per hour. So we run the machines faster. And on the other hand, we do automatization. And third part is we do not waste any material. So that means here in my view, let me say in my area, we run mostly all the processes so far with cold runner technology to minimize the waste. So, and then if we go a short comment on raw material, of course, we say we need to be taken care that we not jeopardize the cost of running the machine by material which has no sufficient quality. So I think these are the blocks we are dealing or we have to deal. And I make also a small advertisement now. Yes, we have some of this put in our booklet, which is published by Technobits, cost reduction in rubber processing. There's also a chapter on injection molding, and we have also a very small booklet here, understanding rubber injection molding. why I'm saying putting these books on the screen, because we struggled in the 80s and 90s to have a very good view on the process itself and be able to govern the process with process models and things like that. And I think we come closer to a solution for this type of understanding in the beginning of the 2000 and so far. And at the moment I see really, which is a little bit a shame for all of us, that we reinvent the wheel again. So we are starting again to developing a lot of that what we have already worked out in the 80s and 90s. Okay, with this I want to hand over to Devin.
Hello, everybody. I would like to thank Param to give me this opportunity to be part of this honest panel. I mean, it is a great honor to share space with Dr. Graf and EP and Karthik. So, talking about the subject, I would be talking mainly of cost of molding, particularly injection molding. And this is a very interesting subject, but it's also a very vast subject. There are so many factors those influence cost of molding, and we will go through it as we speak more into details. But mainly those costs can be categorized into capex and opex, we call it. Capex is basically all the capital investment and the influence of financial cost on the part, every part, and OPEX is the operational cost point of view. And they both are interlinked. They both have different influences on cost per piece, and we will see how we can control or we can optimize each big factor out of that as we go along. Yeah, I would be okay. I will use some slides. So this all, the cost saving, I think, starts from the planning phase. I mean, if you have to be very careful about the cost of molding before you select a machine or a molding process. And maybe we can go to the next slide, Param. The most important thing is to see where you stand, yeah, as a company. What is your situation? What are your goals? What are your limitations? I mean, a molding company in India would think differently than a molding company in Germany, and a molding company in Thailand, or molding company in US. You have all different parameters, and your selection of molding process or a molding machine would depend on mainly about the factors which are influencing your company particularly. Next slide, please. So this is main factors which can affect your situation. So you will have to do a kind of a self-analysis, where you stand, what your company is able to do, what your company is used to do, and how much you can change, or what are your cost parameters, what are your labor costs, what are your material costs, what are your utility costs, what is the cost of space available to you. This changes a lot from country to country, from location to location, and this definitely will influence your selection or your decision, how you want to proceed with the project particularly. Also important is the part here. I mean, what is the part? How critical it is? What are the quantities you want to produce? What is the material? What is the material cost? And your selection of the process and the machine will definitely be influenced by the part itself. Next slide. So molding process is the first decision you will make, whether you want to do injection molding, compression molding, transfer molding, and that is mainly quantity driven and the part quality driven. I would say you won't be doing injection molding just for 500 piece order. So it is mainly quantity driven, but also there are a lot of other factors you would consider. You will then, going more into details, you you will define if you need a vertical machine, if you're producing with metal inserts, or you would select a horizontal machine if you have bare rubber parts which can be easily demolded using brush and without an operator. Then, of course, very important is the selection of the machine size. I mean, having one big machine with a lot of cavities doesn't necessarily mean the output will be high. More cavities, your efficiency goes down. You need more cycle time for loading, unloading. So we will have to do. I mean, the analysis has to be done. What is the overall output at the end of the year? Does two smaller machines give you more output than one big machine? And it all depends upon, you know, how much automation you want to do and what is the labor cost in your area and what is the skill of labor available in your area. So next, the big decision is, of course, cold runner block, whether you want to use or hot runner. That again depends on the part itself, the compound cost. But I would say, I mean, last 5 years we have seen almost 90% projects are with cold runner block. It's no more a decision. It's almost given that compound wastage is not possible. No customer is paying for compound wastage. They just pay you for the part weight, and that's what you should actually cure. And so cold runner blocks nowadays is not a big topic to select or talk. As far as possible, it has to be part of the project, because compound costs are going up, compound availability is a problem, and there's also a demolding time. When you use hot runners, you need additional time to take out the hot runner out. When you're talking about cold runner blocks, again, there are different options. Yeah, you can have cold runner blocks with limited number of nozzles, and then you have small vestiges. Or to the other extreme, you can have wall gated cold runner block where you have zero vestige. You can directly inject on the part. But that again depends on the part, compound cost, and you know, everything has to be. You have to do cost per piece analysis. How about what is your investment? What is your benefit? And then you make a decision based on that. And again, as far as the demolding is concerned, yeah. So you have to again make a decision whether you want to do it manually, whether you want to do it semi-automatically using shuttle sliding devices, or you want to do it fully automatic. The one red flag here is rubber parts are not that easy as plastic for fully automation, because plastic, when you inject, it shrinks into the cavity. So when the mold opens, the plastic part is already smaller size than the cavity, so it's easy to demold. But rubber, when you inject it, expands during the cure time. It sticks. It is under, you know, it is very difficult to push it out of the cavity. So fully automation of a rubber product is a challenge, and has, I would say, considerably higher cost as compared to plastic part, I would say. So you will have to reach an optimum decision whether semi-automation would do for you or a fully automation is a must for you. And all the machine companies, you know, I mean, like us, we give all this guidance, we do all this analysis for you. It is more economically viable for you, or which is more cost saving. That's the subject what we are talking about, where you will actually save money without affecting the quality. Quality, of course, is the top priority. Yeah? So all these things, basically all the cavities have to be filled at the same time, and all the parts have to be demolded at the same time to get the best quality. So that is the key principle behind this. Next slide. Talking about cost of molding, we are basically talking about two things: capex and opex. Yeah. So let's talk about capex. Next slide, please. Capex is basically all the finance cost. It is, you know, your what is the price of the machine, mold, cold runner block, automation, your deflashing devices, QC, packing equipment, land and building. All these are very transparent costs. You see them. You have the quotes in front of you. It's very easy for the top management to see what you're talking about. The figures are very clear. The costs are very clear. And capex is basically only a one-time thing. Yeah, it is basically you just invest once, and then it is reduced every year. It is depreciated every year, and this is going to go along only 3-5 years. You will have to carry this cost with you. But the bigger influence on a cost per piece is always the OPEX, which is we can go to the next slide. OPEX is basically, it has a lot of influences like cycle time, your downtime, wastage of rubber, wastage of power, water, air, space, labor, deflashing labor, maintenance, the downtime. There's so many aspects. We'll go more into the details. But what I want to say is, as compared to capex, OPEX is normally done at plant level. It is part of your plant overhead. Yeah, your top management never sees individual bill of every machine, how much power it is consumed. These costs are very hidden costs. They are not clear for the top or the decision makers. And this is the biggest problem, is that these costs are normally not considered while making decisions about capex. But capex and opex are completely linked. Every decision you make on capex will affect your opex, and opex is going to stay with you for next 25 years. Yeah, capex is just going to be there for 5 years. And most of the cost per piece analysis, what we have done over, I would say, at least for 20 years, is it is almost 60-40. 60% is always cost of OPEX, 40% is the capex. But OPEX is very difficult to define. It is very difficult to calculate. So you need to make an extra effort to actually go more into details of OPEX and then compare your capex decision based on that. So don't ignore OPEX, because that is what is going to really affect your cost per piece. That's the main thing what I want to highlight. Yeah. We'll go into each aspect of OPEX and CAPEX once we talk more into. So next slide. Okay, we can go into the details afterward. Maybe I will now give the forum to Mr. Karthik and share his pains with everybody.
Good evening, friends. So I think EP, Hans, and Deven have covered almost everything there is to be said, especially with that wonderful presentation. But let me try to do my bit. So first, I would like to thank TechnoBiz and all the panelists for having me here. And I hope it will be a good knowledge sharing session for all of us and the participants. First, cost reduction is a very vast and very actually ancient topic, I would like to say. And I hope to touch on some of the key aspects of it from a business point of view. And of course, to learn a lot more about it, from the material, process, and technology point of view from all of you. What I would like to first say is cost reduction can be approached from a strategic, there is a long-term or a tactical short-term point of view. But first, I would like to emphasize on the philosophical import of it. That is, see, invariably an entrepreneur has a different mindset, and it's a multi-dimensional role. Being an entrepreneur is a multi-dimensional role. You have to think about the market, the customers, the labor, the people, the materials, and so on and so forth, the government most of all, and so on and so forth. So with all that, there is a certain level of inertia and a mindset that cost reduction may not be possible, or it is something which has to be borne by the customer. But first, what I would like to emphasize here, if there is any doubt in any of the participants' mind, that cost reduction is a social good. Cost increase is a social burden. We do not want to see all the commodity prices all around us escalate constantly, and it causes a vicious inflationary cycle. So it's not it's not a good thing for anybody and society at large. So that is the first point I would like to drive in here. And then moving on, cost reduction can be thought of in so many ways, in terms of material sourcing. So sourcing is a very important part. Invariably, in general parlance, cost reduction is equal to polymer dilution. But I don't think that should be the case. That you can dilute polymer, but without dilution of properties. So that is something which I'm really looking forward to knowing from EP and Hans on this very important subject. So of course, material sourcing is something which is of great importance. How to procure the same materials at a better cost is always what we are looking for, so that we are not impacted by extraordinary price rises. And then there is, of course, continual improvement of process and process efficiency and productivity improvement. Herein, I would like to say that one of the key things in maintaining cost is capacity utilization. Capacity in terms of both plant capacity as well as using the real estate of the press in terms of molded products. So as an entrepreneur, though, I mean, I've heard Devin talk about more cavities is not equal to more productivity or more, throughput. But what generally we try to do is to maximize the real estate utilization of the press real estate that we have. That is an absolute imperative for continual cost reduction. So initially we may go with a certain number of cavities, but uh, as we understand the product better and understand the nitty-gritties and the specific requirements of the product better, we try to maximize the number of cavities, so that in turn directly falls down, I mean, accrues as cost reduction. So that would be probably one of the easiest ways of doing cost reduction. In that area, what I would like to say is, while we maximize the utilization of press real estate, we try to add more muscles to our people. That is, we try to do fixturing, low cost automation, and try to do a whole host of things. That is where the real entrepreneurial spirit and the engineering spirit comes into play, where we try to really enable the operator on the shop floor to try and maximize the output without causing operator fatigue or overworking anybody, because ultimately labor is our biggest strength. HR is our biggest strength, irrespective of the equipment, material, etc., etc. No matter how good the equipment, no matter how wonderful the material, you need a person to come and switch on the machine. So that person is the most important person aspect of the whole enterprise, is what I would like to emphasize here. Then, of course, we have waste reduction. Waste reduction in terms of primarily rejection reduction. There is a lot of areas where there will be gap in stock. We would have assumed that we have produced so much based on some data, but invariably there will be a lot of missing stock. So that has to be brought together, and all the leakages have to be tied down. Waste reduction in terms of rejection reduction. So when we go for rejection reduction, again, that will impact the quality of materials that you purchase, the type of equipment that you have, and of course the human resource. That is, the human element is the key to resolving most of these issues. So that is about waste reduction. Then you have reduction of various non-value added activities, as EP was touching on, that there is duplication of work, or invariably if there is a compound that gets mixed and it does not reach its properties, we'll do remixing of it and remixing of it. And all these kinds of things should be weeded out by correcting the process primarily. So that would the more we refine our upstream processes, the better our throughput, the more there is better utilization of our downstream capacities, is what I would like to emphasize here. and so on and so forth. Then there are obvious things like inventory optimization and logistics cost reduction and inventory carrying cost reduction and so on and so forth. So these are the various areas. As far as human resource is concerned, the primary method of achieving cost reduction there would be to go for de-skilling. De-skilling will really help in reducing costs. There is no point, or it is highly counterproductive to try and cut corners with our workforce. But rather, it is much better to go for de-skilling so that the operations become much easier, the throughput naturally increases, the specialization of the operators automatically increases because the skill requirement is kept to a minimal. So that is an ongoing process. All these are ongoing processes. There is no silver bullet to cost reduction. So it is a multi-dimensional role for an entrepreneur, and I guess all these areas have to be touched upon on a continual basis, and it should ideally be made as part of the culture of the organization, whether instead of reacting to global events like COVID or price escalations, if we make it as part of the culture of the organization to constantly improve and keep refining our craft, that would eventually, I guess, lead to a lot of dividends in the long run. So that would be my opening comment.
Mhm.
So Hans, I would, and EP, I would just pose this question to you. So what would be the ideal way to go about polymer dilution without property dilution?
No,
Because
first of all, it's in the material side. First of all, in any product, when it is performing, only the polymer will degrade. The ingredients like fillers, they never degrade. So our selection of filler plays a very important role. Many of the formulations, they simply go into very highly reinforcing fillers with a reduced quantity, which ultimately end up with a very high compound cost. So we need to understand what is the customer requirement. According to the customer requirement, we must design the filler system. See, especially in the molded rubber products, where the application is more on the sealing and the vibration, there is no need to add very high reinforcing fillers like HAF, ISF, etc. So because many of the specifications, the OEM specifications, they don't require a very high tensile strength, etc. So it's a good practice to have optimum tensile strength, and by selecting the appropriate fillers, you will gain a lot of processability, and also you gain in cost. This is from the filler side. Apart from that, in the polymer, see, let us not call it dilution, polymer dilution. So people say the polymer is less, the product is the compound is inferior. No, if the polymer is less, the product will perform better, because the polymer is one which will degrade. The carbon black will not degrade. The filler will not degrade. So it's a question of the ratio. It doesn't mean that we have to always aim at meeting the functional requirement. So the filler selection, and also selecting the appropriate accelerators. Many of the formulation, we should not use conflicting materials. Too much of tachyfire and too much of mold release agent together in the same formulation will be a conflicting materials. So we have to avoid all the conflicting materials. Select appropriate polymer for appropriate process. What polymer to be selected for injection molding, what polymer to be selected for compression molding. The concept of the pressure generated in the compression molding is different from the injection molding. Accordingly, we may have to select the polymer. The polymer selection, filler selection, these things plays a major role. It has got an effect on the cost also. So there is no fun in making, when a customer asks for a 15 megapascal, you develop a compound with 20 megapascal strength. You are not going to get any benefit. Customer is not going to give benefit. On the contrary, you are going to have a higher modulus, and you will have more process issues. So for example, in the case of silica, we always remember about silica 175 surface area. Okay. Whereas there are silica with 125 meter square surface area, which is very good for the molded rubber industries. Whereas many people may not be aware this kind of silica also will work. That is a medium, that is lower surface area silica is very much useful for the molded rubber products, which industry today is not much aware. So like that, we have to see to the function of the individual raw materials and not to attach too much with the brands. I believe in chemistry. So we must attach to the chemistry of the chemicals rather than the brands and trade names. So that way you can optimize your raw material. You got an option to select. When you have an option, automatically the raw material price also you can bring down. Well, it will automatically bring down the cost of the compound, etc. So this is my view with respect to material. I think I have answered your question a little bit. Okay. So, Dr. Graf, we have any other view? Yeah, please tell me, Karthik.
So it's my turn now.
I'm sorry.
Yeah,
Please, Karthik, please put a question again.
Yeah,
Yes,
let me go back.
in the scheme of in the scheme of an SME, or in the rubber industry, since there are so many raw materials that are being used, and it is not like a sheet metal industry where you just have one raw material which is used and it can be easily tested. When there is a multitude of materials, how do we go about understanding whether the batch to batch consistency of the materials that are coming in are affecting our product and our process? Because that is the primary reason why we would like to stick to brand. Otherwise, we have no specific affinity.
No, basically, when you are going for a change of a raw material, you must always validate change at one time. If you don't have much facility, so if there are FTI or some chemical analysis technology, if I can't force a small and medium scale industry go into an investigation of raw material, which is a non-value added activity. So I suggest a simple method is to, in your running compound, you are changing one chemical, please change the chemical, run the compound, and don't compare. Many of the people do mistake. They will compare against the specification. They should not compare against the specification. If at all you make a rheograph, whatever it is, you compare versus the current compound, standard material compound, versus an alternate material compound. Compound to compound comparison should be there. Then you can understand the trend. Is it causing any disruption in the any of the compound? This is my advice.
Thank you.
Dr. Graf, sir.
Okay. I think the term polymer dilution is very interesting from my side.
Okay.
First of all, let me make a comment. Historically, we started with very simple compounds, and due to history and changes here and there, our compounds become more and more complicated. And I think it's over time to go back to the roots and say a compound must not have 20 ingredients or something like that. I believe a good number is in between 9 and 14, 15 max. So if we say so, then we have to acknowledge that there is a linear relationship between the term dilution and properties. So that makes it, first of all, simple and straightforward. So when you design to spec, let me say you have to meet a tensile strength of 10 or something like that, you know exactly from the old compounding tables how much carbon black or whatever filler and oil you have to use to achieve this value. And we had a tendency in the past also to over-engineer the compound. Yes, so we give the compound to a customer, automotive, who is not paying anything for that type of properties, which is over-engineered because he was not demanding that. The only thing what is the difficulty here is that we have a lot of things not written in the spec, and that is his lifetime expectations. Yeah, for an grommet or a bellow or whatever. So we have to look at that type of properties which is not written in the spec, and all others is pretty straightforward in which you can work out in experiments or in very simple experiments. Actually, they are not too complicated. So, and then we have things to consider when we do selecting now. Let me say we need an EPDM, and now we have to ask ourselves what kind of EPDM I should use. And that is mostly a matter of viscosity, because the machine has so much power, yes, and a very high viscosity compound, you may not be able to push that through your runners and gates in the cavity to have a certain pressure there. Yes, so you have machine conditions which are maybe a limit, and here you have to take care that, and I put that all under the umbrella term viscosity, that the machine is able to process that. Or you have you are able to do adjustment, and that is the dimension of the runners or the length of the runners and things like that. Yeah, and that's also no, I need to stick to your comment, and that is dilution of polymer. So you have simple technology behind that. You dilute the polymer, and that affects your properties in a certain way. And when you now do that and you have your compound there, yes, then you have your vulcanization kinetic. And here I think is most of the misunderstanding between the engineers and the chemists, because mostly I have a machine as a chemist. There is a machine, there is a mold, and now the boss comes and say, now run it. Yes, so that means you have given edge parameters, yes, which you can hardly question. And but what you can do, you can adjust your cure. And when you do that, there is very little understanding at the moment from the perspective of let me say, govern the injection molding process, for example, how you have to change your cure to get the optimum output. And if you ask that, then you have to question what is a time-consuming step in injection molding. Yes, and that is when the compound goes in the cavity and waits for it to be heated to the mold surface temperature. So, and with this question, I think you can easily now optimize the molding process. And I'm turning back again. That is all written in this nice booklet. So excuse me for that. Yes. To explain that, why I'm so thankful that actually we put that together, is I'm translating that at the moment into German language. Yes. And I was surprised how much information we put in there. So I didn't know that to full understanding when we managed the English version first. Yeah. So it's very funny for me, yes, and of course a little bit surprising. And then coming back to the operator, yes, the operator with her assistants, which are the engineers behind them, yes, and we need to train them to talk the same language, to understand each other, yes, because they're using mostly different terms. And that is one condition. And the other is the choice of the machine. Towards Maplan, I have to say modern machines are very precise, number one, so the repeatability is there. And the information in the machines are much more than we use. Yeah? Mostly we use like Microsoft Excel, we use 10%, but we have 90% left, which we do not use. Yes, and here even we have today's systems, which is developed by CAS in Hamburg, which is, I think, implemented in the Maplan machine as well. Yeah, where you really can make this process as transparent as possible as we can do today. Yeah, so now it comes to the question how to optimize that. And that's what I tried to point out in the introduction is we need to have more people who understand this process. And I'm talking about injection molding mostly, and not so much compression molding or other techniques, because here from a European standpoint, that is our mass production. Yes, everything what we can do, we do injection molding because it gives us more output at the same time. Yes, so the cost per hour to run a machine has to be low. That is a European situation for the last 50 years or so. Yeah. So, and even it doesn't work so nicely when we say, okay, we need to decrease the labor cost, so let's go to India or somewhere. I mean, that is all the past. Yes, that's not working anymore in any country. So that is gone. So now we need to focus on maximize, yes, maximize the output, and then you have a nice measure on efficiency, and that is when you have the planned output, what you have scheduled, and the real output, yes, and then you know if your process is okay or not. So any
So I totally agree with you. We had a similar experience a few years back, wherein we had a compound which was just not working, and we had been constantly tinkering with it, adding more ingredients and more ingredients, more process aids, changing the proportions, changing the curatives, etc., etc. And eventually we realized that we had just gone too far, and then we went back to the basics and just used the exact number of ingredients that were absolutely essential, and most of our problems got solved that way. So uh, uh, you just bang on the money there. So that was a real life experience for me. So,
Yeah,
one comment. If you look at Michelin, yes, Michelin has let's say the culture, not religion, the culture that they say this is the compound developed in the lab, and now you engineer, you do not question the compound, you even do not talk to the compounder. Yes, that's forbidden. You have to work with that. Yes, and sometimes I wish we had that power as well. So we are a little bit softer here. Yes. But again, if you see in your teams or elsewhere compounders which are fooling around, let me say that this way, yes, and not are up to date with the basics, then you should provide them education. Yeah, I know that all institutes in India and elsewhere in the world, they provide a lot of theoretical knowledge, which you are not necessarily be able to use in practice. Yes, there is a gap in between that. And all my life, I try to bridge that type of gap, but it's still there. Yes, so I was not very successful. Sorry about that. Okay.
Maybe I would like to share my next slide because it also touches a lot of points to what Dr. Graf said and Karthik, what the concern what you raised. So okay. So let's go about this. Yeah. So talking about cycle time. Yeah. Cycle time actually starts with the mold design. You will be very surprised, but actually it has a lot to do with mold design. It starts from the size of the gate you're using. You know, I mean, I would prefer to use 2 gates of 1 millimeter rather than using 1 gate of 3 millimeter thick, because that directly affects your cure time. That can be, 25-30% higher cure time just by using a slightly more size of a gate. And you know what practically happens is, because your boss is after you, where is the mold, where is the mold? So you directly make bigger gates than required, because you want the mold to be okay in the first shot, and then everybody is happy about it. But they are only happy for a day, yeah. And the whole next 5-10 years of the product life, you will be unnecessarily using much higher cure time that would have been required. So you have to be very critical about size of the gate. Your parting line can make a lot of difference. A wrong parting line can really increase your cycle time. Let's, for example, a bush, rubber to metal bonded bush. If you have a straight parting line, your bush can stick top cavity, it can stick to the bottom cavity. The operator has to go and take off the parts from the top cavity, bottom cavity. You cannot do automation, but just a change of the parting line where it is locked in the middle plate, and then the middle plate can be split. You can control the cycle time a lot. Then you can make sure that everything stays in the middle plate. You can load all the parts very easily, and there is no waste of cycle time. Same way, mold automation. Mold automation means the mold design itself should help demolding to a certain extent. Like using high pressure air blow for bellows. It should happen within the automatic cycle, so that when the operator is there, the parts are already off the core and lying loose, so he just had to take them off. He doesn't have to really blow them off. Or there are so many things you can do in the mold, which eventually helps reducing the cycle time. Like I said, the bush, if you make a parting line, a straight parting line, it's very easy to make the mold. You just go on a boring machine, make the holes, that's your middle plate is done. But if you follow the parting line, what I said, you have to go for CNC milling. The mold cost will be 3 times, but then your cycle time will be half. But those decisions the top management has to make, whether they want to spend money on the mold so that the cycle time is reduced, or it's under control, or you want to make something cheap and then live with higher cycle time and wastage throughout the cycle of the mold. Yeah. So then injection molding machine, when it is open, it is adding to the cost. We say keep the machine as less open as possible. Open machine or idle machine is always adding to your cost. So try to use 2 plates or shuttles or whatever possible to make sure that the machine is closed as much as possible. When the machine is closed, you are making money. The machine is making money for you. Either it is injecting or curing or whatever. When the machine is open, it is adding to the cost. So try to talk to the machine supplier, or try to have your mold design in a way that machine remains open for as short time as possible. Third is you can use the machine technology to reduce cure times. As Dr. Graf said, it's all about converting injection pressure into heat, so that you do most of the work before going into the cavity, so that you need to do less work in the cavity. And rubber is a bad conductor of heat, so it is better to give as much heat as possible before the rubber is entering into the cavity. Of course, You have to make sure that rubber is not getting scotched, but you need to reach that balance. Yeah. And there are a lot of machine features available to help you with this, and that needs to be fully explored. And uh, uh, just Karthik, one clarification. I was talking about when you are buying a new machine, you should not buy unnecessarily a big size press. But when you have a machine, you should use the full pattern size. I mean, as much as possible. You should put as many cavities as possible. So I'm not saying that if you have a big machine, don't use more cavity. But when you're buying a new machine, don't just unnecessarily buy a big machine thinking that it would be cheaper. It's not like that. So, but when you have a machine, you should definitely use full as much capacity as possible of the press. Yeah. Then the second cost is the production loss. See, all these things, all these calculations, capex, opex, are finally divided by output per hour, output per year. Yeah, all your costs are finally going to be divided by output per year. So if this factor is low, your cost will be high. So you need to produce more. You need to have less production losses as much as possible. So you need to have a machine which is more reliable, or machine where machine manufacturer can help you fix a problem as fast as possible. And your maintenance department should do the preventive maintenance. My experience, we have seen that companies who do PM, they have much less unplanned downtime than companies who are not doing PM. Yeah, and every machine needs PM. Maybe, I mean, everybody, Maplan, Desma, Rep, whatever you name, PM is very important for a good health of the machine. Yeah, and rubber machines particularly are under extreme stress. Rubber processing are very stressful as compared to plastic. Yeah, and rubber machines need to be taken care of, and that would help you to keep machine availability high, and that definitely reduces your cost per piece, because what you're dividing is with a much higher figure than. Yeah. Process waste, this is very critical area. So we can talk about labor cost. Labor cost, of course, you can eliminate or you can reduce by using automation. Depends where you are, which country you are. One operator can operate number of machines. That also depends how the machines are laid out, and if you're using more runouts or shuttles, so that operator can easily reach multiple machines without making a big physical movement. Your mold design also decides how much deflashing will be required. If your mold design is good, if you have proper overflow grooves, which can be trimmed by the operator itself, you don't need a deflashing stage. There are a lot of deflashing which can be reduced by using good mold designs and by using accurate injection molding machines, which are more repetitive. Of course, horizontal machines, nowadays we are selling more and more horizontal machines, because for many parts which are not using metal inserts or something, you can do automatic demolding using a brush, or using simple demolding devices which are not very expensive. Even for countries like India, China, they are viable. Compound wastage. Compound wastage is a very important factor, because as we are all talking about reducing compound cost. So just by using a cold runner block, you can reduce 10% of the compound cost, compound wastage, which is as good as reducing 10% of compound cost, which how it is. We have been talking about so many things you need to do to really bring down the compound cost. It is much easier to save compound wastage, which is much easier and which is in your control. Yeah. So using cold runner blocks, there are three types of compound wastages in a injection molding process. First is the real designed rubber wastage. It is the weight of the runners and gates, which are part of the mold design, which you know how much it is, which you can calculate in your 3D model. That can be saved by using cold runner blocks. There are a lot of machines I have seen where customers purge rubber compound between cycles or every cycle, or that the operator will take that wastage and put it in the waste bin. Nobody knows how much was purged. At the end of the year, you must be, I don't know, thousands of rupees in this wastage, which is really never traced back to the to the cost. It is just overheads. So those things should be stopped. You don't need, if you have a good machine, you don't need to purge compounds very often. Then there are then there is also a lot of wastage when you change compounds or when you change mold. Some injection unit designs need lot of rubber to be purged to really get it cleaned, particularly when you change colors. All those things can be saved by using the right injection unit design, which needs less rubber wastage. This all is a waste finally. No, your customer is not going to pay for this. Yeah? This is all your saving, your in-house saving. That is directly profit. Energy. Rubber processing is a very high energy consumption process. Yeah? The rubber, you have electrical power and you have heating power both. So electrical power nowadays you can save by using servo hydraulics. We had traditional hydraulics, then we had hydraulics last 20 years. Now we have servo hydraulics, which are almost 40% power saving. I mean, we have Kaplan is now supplying 95% of its servo hydraulics. We have almost gone away from normal proportional hydraulics because it makes a lot of sense. It is directly 40% saving of the electric power. And the second aspect is heating. There's a lot of heating power when you're molding rubber parts. So it helps a lot when you can insulate your molds, insulate your heating plates, insulate wherever there is a radiation losses, and that saves you a lot of money at the end of the year. This seems very not very important thing. Not many customers do it, but those who do it, they have made tests that they have saved thousands of dollars by just insulating their molds. Particularly if your molds are thick, it's a big cost saving. So all these things help you. Cooling water, particularly countries like India where it's hot, there's a lot of consumption of cooling water. Injection molding machine needs cooling water to cool injection unit, cool the hydraulic oil in the tank. So machines, when you use servo hydraulics, you need very less cooling of the hydraulic oil. So you save almost 40% of cooling water requirement. I already told you compound changeovers. I mean, when you change compound, you change colors, you can stop that with wastage. Mold changeover times. This is also a big factor, because if you can use preheated molds, you can change the molds much faster. I have seen customers changing rubber to metal bonded part molds in less than 10 to 15 minutes. We use preheating stations, but that at the end of the year can give you almost 3 to 4 days extra output. It's a lot of money. So this you should plan. You should have a proper jig or a trolley where you can push the molds out or push the molds in. You should use quick clamps in the mold, or you can use linear bearings on your heating plate so that the molds can be changed very quickly, because this is all waste of time. The mold change time is waste of time. Nobody is paying you for that. Your customer is not paying you for that. Nobody is paying you for that. So all this wastage has to be stopped or reduced. When you're buying a new press now, you should always look for is it ready for the future. Maybe India doesn't need fully automation now, but maybe after 5-10 years you would need it. There would be labor issues, availability, all those things. So your machine should have that possibility to integrate complex automation as you go along. Remote access for quick after sales service, so you don't have to wait for the engineers to really come down to your factory and solve the problem. Nowadays, it's possible that the machine supplier can directly log into the machine, see what's wrong, and then they can send you the right part, and that your machine is online as quick as possible. Industry 4.0, of course, most of the machines have to be ready for Industry 4.0 now. That's a given. That's a discussion anymore. And of course, maintenance cost. You have to see how much machine warranty that your machine supplier is giving. What are the spare part costs? How frequently you need spare parts? Some machines which are some cheaper machines, they need a lot of spare parts. At the end of the end of 5 years, if you see it's the same amount you would have paid for a European press. So and downtime is very bad because it is the sales revenue loss. You are losing opportunity cost. It is not only the cost of that shift or those parts which are missing. You cannot sell those parts in the future. Yeah, that's opportunity is gone. So the cost of downtime is actually very high for the top management, particularly. Not may not be for the production or the maintenance guys, but as far as the top management is concerned, downtime is a big cost. And again, the preventive maintenance, that culture has to be developed in your company, that your equipment is you do the PM regularly to keep the machines, unplanned breakdowns. I mean, you can plan PM work, yeah? You know when you're going to do it, so you don't really have production loss, although same time is required. Next slide, maybe. CapEx. When you're CapEx, again, expensive machine doesn't mean expensive parts. Yeah, expensive machine can actually, or most of the time it means it is lower operational cost. It will save power. It will be faster. It will be more accurate. It will have less rubber wastage. You can have less labor. There's so many things. So you have to be very. Don't just decide on the machine cost itself, the upfront cost. Go more into the OPEX part of it and try to understand why you're paying a particular price to a machine supplier. What you're getting against that. How does it help you to reduce the OPEX? Yeah, lead time, of course. If there's a 3 months gap between two different suppliers with the same quality, you would lose 3 months of sales. So obviously, lead time is also very important. When you're buying a machine, you normally, you see if the machine is going to last for only 10 years, 20 years, or 25 years, and that definitely reduces the capex per part. Yeah. We talked about uptime. We don't have to talk about it again. Operating height, as you said, Karthik, the operator is the actual customer. Yeah, he's the end user of the injection molding machine. Is the operator. So if he's not comfortable, it does affect the cycle time. He gets tired very easily, or then the cycle time is affected. So operating height, easy access to the mold, safety of the operator, all those things are very important to ensure that the cycle time is stable throughout the shift. It's not like only in the morning when the operator is fresh, the cycle time is good. As he gets started, the cycle time goes up. That should not be the situation. So machine design, machine ergonomics has a lot to do with it. Machine footprint in some countries or some big cities, even in India, where the space is a big cost, it makes a difference how many machines you can put in this particular available space, and how many operators can. I mean, one operator can operate how many machines. Of course, communication. Yeah, if your machine control is very complicated, as most European is, you need a high-skilled operator. We had customers in India who had engineers operating machines because the machine interface was very complicated. It was not easy to understand for simple lower skilled operators. So it is better to have a control system which is easily understood by the level of labor available in your area. It would be different in Germany, it would be different in US, Mexico, Brazil, India. So because the salary level of the operator will change as per the skill level. At the end, for injection molding, operators just need to take the part out. So in a lot of customers, only girls operate the machines, or very low level, low skilled operators can also operate a machine. Compression molding needs much more skill than a injection molding machine. So, but the control system can make the demand high. So that's something you have to be careful with that. So these are the main factors I wanted to introduce, that you have to be careful with this. Yeah. Any questions about this? We can go into more depth.
Yeah. Thanks for the perspective, David.
Yeah.
Just a few points which I thought I would mention.
Yeah.
It's only occasionally that we are able to, plan a whole machine purchase against the project or a specific order.
Yeah.
Invariably, we have the machines and we have to use them to produce the parts that we get orders for. That is what happens most of the time. So in that perspective, we would like to, maximize the throughput, at least on a stage-by-stage basis.
Absolutely.
So that was one thing. Then the other thing which you were touching about compound wastage, for the benefit of people who are in compression molding or transfer molding, I would just like to mention that a use of a preformer or a servo-based cutting machine can go a long way in reducing wastage, and also ease the post-processing of products, because a heavier flash results in rejections or aesthetically unappealing products, or difficult post-processing, and reduces the throughput of post-processing. So the more we concentrate on upstream processes in terms of consistency in compound mix or preforming activities, the ease in throughput in downstream activities lends itself to great cost benefits. That was one thing which I wanted to touch on. Then I just had a question for you, Devin, that is it likely that there will be injection machines that will come which will suit low volume production as well? Because the dream is to simplify the process. So, invariably, the purchase of injection machines is marred by a requirement for very high volumes and continuous running of specific parts, or dedicated usage of a machine for a specific part. But most people have a multi-product or a multi-component discipline. So in that view, are there any methods for selection and usage of injection machines? Is it likely that there will be new technologies or new machines that will come which will suit low volume production as well?
Yeah, I mean, there are some solutions. We particularly face this situation when for the oil seal customers, yeah, they have too many different sizes, but each quantity is less, and that becomes a challenge. But in this case, of course machine normally for the sealing industry, if you see, they only prefer 100-ton, 160-ton machines. They don't go for big machines, or even C-frame machines, yeah? 50-ton, 25-ton, single cavity, 2-cavity molds. But in this case, you can have a common golden block, or which covers most of your range. So that particular plate doesn't have to be changed. And then you have a master mold where you have quick change cavity inserts. Those can be changed. So that can take care of a particular group of a product within a certain range. And there are also family molds. When you have wall thickness is almost same, only your diameter changes. Your cure time is almost the same. In this case, you can produce different size of parts in the same mold. But as far as the machine manufacturers are concerned, we have now quick clamps where you can really change molds in 5 minutes. So and particularly in case of Maplan, there's only 5 or 10 gram of rubber left in the injection unit. So it is very quick. You can change even compounds very quickly. So I would say in half an hour you can really change from one part to the next part. And you using a smaller machine helps when you have less volumes. Yeah. So but again, then try to avoid hot runners. Try to use a common cold runner block so that you don't have to manufacture hot runner plates for every every small volume, a small part. Once you have a cold runner block, it's a compression mold, right? It is almost the same thing. Once you have a cold runner block, there's not another big difference between injection and compression. So that helps. But yeah, smaller machines have their own use, and typically a small volume runs. A lot of customers, they have 1,000 parts, but only 1,000 pieces each or 500 pieces each. They prefer smaller machines, C frames, and with quick mold changes and all those things. Yeah. So yeah, it's possible.
Thanks, Devin. The presentation is excellent. We are the knowledge level, the details are so good, which we cannot just like that get it. In fact, it will become like a book. What Dr. Graf was showing, we can also publish a book on this presentation. So very nice.
Yeah, same observations. Yeah, I'm sure.
Very nice presentation. Mr. Karthik also has put up his ideas from the 360 point of view, and all the especially last point what he mentioned about the preform is a very good thing for the especially medium and small scale industries. Those who have been using all along with the cutters and etc. Nowadays the preformers, earlier preformers are used to be imported at a very high cost. Now it's a lot of economic models are available, so that it's a very viable tool where a lot of rubber compound saving can be achieved in this. And almost I think we have touched upon all the subjects, some little bit of compounding and the machineries in details and overall cost components by Mr. Karthik, and Dr. Graf giving the fundamental concept and approach towards the cost optimization. I think Mr. Prem, I think we have covered almost we have done our justification in touching upon all the subject. I hope I am waiting for Mr. Prem to conclude. Mr. Prem?
Oh, well, I was expecting some more ideas for the people to learn. Okay. Dr. Graf, you want to add any additional points? What else can be done to reduce the cost? We have written the good book, published. Technovis has published a book. I think you did all the work, making a book happen in 300, 400 pages of a book only on the cost reduction rubber processing.
Yeah. If you see the people need to work on that topic, cost reduction, first thing is they need to identify the cost drivers. Yes, and we have named a couple, and that is, for example, the time for the temperature rise in the cavity. We have one cost driver not touched in this, and that is mold fouling and mold cleaning time, which is surprisingly not really an open issue on top, because production stays mostly in a rhythm, and when they have planned every, let me say, week or every second week a cleaning, so that's a 3 hours, 4 hours production loss as far as I know. And that is a massive cost at the end of the year if you multiply that by the time, how much you do that, and by the number of machines you have in your plant. So I believe that is something which is not really investigated at the end. And it is in the court of the compound developer, of course. So, and then we have the old discussion, multi-cavity versus small number of cavities. I have some examples where the winner is the small number of cavities. If you adjust the compound to that type of surrounding now, yes, short runners, and you don't need the pressure, things like that. That is one topic where you need the interaction between the compounder and the engineer. But in terms of operating window, yes, and in a small cavity mold, operating window is quite large. So you are always on the safe side and you can go in the more efficient edge. In a large number of cavity mold, it is much more difficult and your operating window is much, much smaller. That's one thing, and I lost now the third one. Sorry about that. Just lost it.
Okay, good. Karthik, I have one question for you. You actually excellently put key issues related to the cost issues. You own the company, and you look into multi-faceted issues. Which cost is challenging for you to cut down or to manage?
The material costs are the primary killers, because we have very little control over them, and in the scheme of things, the consumption in terms of even if you think of India as a market, the consumption of India in terms of rubber is much lower compared to many other countries in the world. So consequently, there is a lot of preference given to the larger consumers in terms of pricing, in terms of availability, etc. So these costs continually cause ballooning of costs. So that is one area which we have no control over, and neither is our customer very willing to, help us out there. It's across the industry. It is not just for me per se. I have interacted with many entrepreneurs and companies, and I've spoken to many of my customers as well. There are very standard price indices for metal and plastics and other such materials, but there is no proper index for rubber, especially for synthetic rubber. You even have things for natural rubber, but and SBR probably, but there are no proper indicators for synthetic rubbers and the multitude of polymers that we use. So that is the primary area of difficulty and concern for us. So yeah, so we have to keep a handle on that. So to just add on to what Dr. Graf was saying, all I have to, the only comment I have is, which he may not understand, is Majburi ka naam Mahatma Gandhi. So when you don't have a choice, you just have to go, and when you're put in the spot, you have to rise to the occasion and make it happen. So I would like to think that we do it more often than not. And I would like to just add on one more comment. One of my customers, the chairman of the company, he always says there is a machine inside a machine. There is one more additional machine inside a machine. If you are able to really open your eyes and cut down all the waste, all the muda, then you will find that there is one more machine inside the existing machine. And I would like to say that we have achieved that. We have at times doubled our output just by understanding where all we've been wasting our time and effort. So with closer scrutiny, it is very much achieved. That's what I would like to say.
Absolutely.
So, Devan, I have a question for you.
Yeah.
You have seen, your whole life, I think, career, professional is all with rubber machines, right? And with you passed at Desma and now with Maplan.
Yeah.
I think you've been traveled all over the world. partners. You work with both Indian, non-Indian, or all kind of cultures. Can you talk about some of the bad practices, where these, mold, particularly the rubber molding companies do a lot, not just machine point of view. I think you've seen operations as well, where they really should look at, I mean, talk about mistakes. What kind of mistakes, whether it is small scale or even the big and large scale companies as well.
India, particularly, fortunately, because of my ex company, Desma, India always had good injection molding machines from beginning. Fortunately, yeah. And Chinese are coming now, but traditionally, India has almost 2,000 injection molding machines with a relatively very good design. But mold has always been a most neglected thing. Yeah? I mean, customer I have seen develop mold in 2-3 weeks. I mean, they just don't care about runner design, gate design, parting lines. The top management is always pushing them mold. We had to submit samples to customer in 2 weeks, which is not possible. Yeah, and they do the SOP PPP with whatever mold they have, and then they keep on running it for 10 years, 15 years, and then they have their corresponding cost. So I think mold is the most neglected area in many countries, I would say. And particularly US, it's very surprising because in US, last 20-25 years, manufacturing has gone out to China, India, Mexico. And now US wants to bring back the manufacturing. We don't have the know-how, we don't have the people. There is a technological gap of 20 years. I mean, I have customers in US who are still doing compression molding with the old places because there was no manufacturing in US for last 20-25 years. Most of it went out. Now it's coming back. It has to come back and has to cover that 25 years of technology gap, which is not in Europe. It's very different in US and Europe. Both are developed countries, but the technological and the know-how. I mean, in US, we say that in next 2 years, we will lose 60% of the know-how. People who are already 59, 60 years old, they're getting retired. They had all the know-how. So now it's a big problem for rubber industry. Yeah. So yeah, I mean, rubber industry biggest challenge is the know-how. I would say everywhere except young countries like India or China, but most of the countries the know-how is being lost, and people look at machine manufacturers to give them that know-how, which is again a big challenge for us. We are no more only supplying machines. We have to supply the complete know-how. Yeah, how the part is molded, everything as much as we could. We could supply. So it's all dynamics are changing a lot. And the machine is becoming a very small part of what we offer now. It's like it is more like a technical consultancy, yeah? Almost so many people, because the know-how lost is a big thing in, I don't know about Germany, Dr. Graf, or in Europe, but in US it's a big factor now. There's
I think it's everywhere in the world, yes, that know-how loss is there, yes, and we're competing on talent already, yes, and we try to lure everybody who can speak a sentence in a good manner, yes, is hired at the moment. That's a German situation. So yes, I think the key of all when we go to cost and design our processes to cost is indeed knowledge about the process, knowledge about the surrounding, and which we explained repeatedly here. And what should I say? Yes, German after World War II. There was all property damaged. There was nothing, no compound intact. Yes, and when you see chemical industry in 3, 4, 5, 6 years, yes, they were bigger than before. So we learned the hard way what means knowledge. Yes, and still, yes, we retire all the experienced person. Yes, whoosh, you go out, you are too costly or whatever. Yes, I don't understand that at all. I don't understand management anymore. Yes, but okay, I'm a technician, so okay, I shut up now.
I think not to worry,
Young engineers, all these young engineers coming out of college, they want to work with a laptop in office. They don't want to go to shop floor where it is, 55 degrees and smoke coming out. Rubber industry will last on their priority list. So
Yeah.
it's going to be a problem for going further. Yes.
So and for my heart, a bit one sentence. Yes, we have a little bit and culture sometimes that the white collar, high educated should not go out in a plant and look and see. Yes, so we stay apart, and I think that's a big loss of senses for the process. Yes, a lot of people who are designing compounds or designing molds or what, they don't know how to run a machine, something like that. Yes, and that is all nonsense. Yeah,
No, that is
it should not be that way. Yes, and I was in different countries as well. So I had a boss when I started in industry. He forced me into that. Yes, he would never have accepted. I never thought about that. So I spent more time in the plant than on my desk. Yes, but I had a trouble with a lot of bosses. Yes, because I could not respond to their email. Okay, sorry about that.
Yeah, Karthik, you want to say something? You were saying something. Yeah.
No, I was just saying not to worry, the AI engineers will take over from the humans. So, to bridge the technology gap. But nevertheless, as Devan was pointing out, what in my personal experience, we really have to work on the molds. And it does not immediately mean that we will have to go for an extraordinary tool maker who will charge maybe 5 times what our existing tool makers do. It just means that we will have to work very closely with our existing tool makers and have a very comprehensive dialogue on how the part, the rubber is going to go in, how the part is going to come out, and then how we are going to maintain the mold if it has too many moving parts, and then just think about it in its entirety, and that kind of dialogue, and you have to develop a relationship with your tool maker and go at it, and then that eventually results in your own evolution as well as your tooling partner's evolution. So in the next mold, the basic things that issues that we face in our shop floor is not understood by the tool maker simply because we do not tell him. So consequently, the skill level of the tool maker is going to remain the same. And then we keep lamenting about the fact that we don't have good tool makers. It is just a futile ramble that we go on. Rather, if we go and sit across the table and then have a nice chat over a coffee or something, and then talk and then take the 3D model, work it out, look into it in every aspect possible, and then keep making even small incremental improvements. It does not mean we will come out with something revolutionary in the first book. But keep making incremental improvements. I may one day walk into Devin's, factory and see some mold, and then something triggers in my mind. I should share it with him, and then he will also enjoy the benefit of that. So I think that way knowledge sharing is quite poor in our industry, and people do not want to give out. They think they will achieve something extraordinary by holding on to knowledge. Rather, the more you give, the better you get. The whole ecosystem improves. Consequently, the dividends are extraordinary rather than just holding it all in here and then trying to do something. So that is, I think, what Devin was pointing to is really right there.
And you know what?
Karthik, one thing.
Just one point is a good mold maker for rubber should have a test machine. Should be able to test his mold. Only then he can start with a 1 millimeter gate, then make it 1.1, 1.2, 1.3. He will then optimize. Otherwise, he will directly make it 3 millimeters, and you will have double cure time all your life. And one more thing I've seen in India missing is only for rubber. Yeah, plastic they do it, I know, but rubber they don't use simulation softwares as much as plastic industry does. Software like Sigma software, all they are not used much by Indian mold makers. So that's also one thing which can be improved. Yeah. So
Karthik, I have got one question. When you're developing a mold, are you getting the mold drawing from the mold makers to understand
Yes,
what is the mold? You do.
Yes, we do. We do.
You do. Okay, that's.
It is a highly collaborative process, sir. Now, I mean, at least now, it wasn't before, but now it is a highly collaborative process because products are becoming more complex, customer requirements are becoming more stringent, aesthetic requirements are increasing. Parts are not going through PPAP audit simply because of some minor tool mark. So we have to really go into the depth of things so that we are able to give that kind of a value-added feeling to the customer. So we insist on it.
Mold makers, they don't part the drawing. They'll give a product, they make the product mold. There was a thing actually.
It is immaterial, sir. Today, frankly, it is immaterial. I can just take his mold after he has supplied. I can take it to a CMM and measure it in its totality and give him back the same drawing that he refused to share with me. So I can make that argument. That again, sir, it is a trust level between you and your tool maker. When you have a good trust level, they know that we will not take a tool concept and then go and give it to somebody. We will always come back to this. That trust level, once it is built, they are also reasonable. And even if we spend about 5-10% extra because of our greater requirements, and not 5 times the tool cost by giving it to some place like Taiwan or somewhere, we get a lot of advantage in terms of cycle time, OPEX reduction, etc.
But what I feel in India, see what Mr. Devan was touching upon a very, very useful point. The gate size. Today in India, the gate size is hypothetical. I have my personal experience for making an injection molding through the years. We have made only in Desma injection molding machine. We made a mold outside where the gate size was X. Subsequently, we made a mold with Desma costing maybe 2X. But they give a very thin gate. We were very surprised how it's going to work. Maybe the number of cavities are increased from a 6 cavity, it has become a 9 cavity. But it has worked very well. So as Mr. Devan was mentioning correctly, as a point of safety, our designers will put a bigger gate so the rubber goes and fills up inside. So that's my practical example. I've seen the mold with X and also X by 2. The X by 2 works better. The curing time is less, which I've seen more nice in my experience past in my own production line. So I really appreciate with the Devan's point and the gate size. Today, all our mold makers in India, they don't use any software. In fact, I had a 1-year license of the Sigma Soft with me.
Yeah, Sigma Soft.
Okay. We have not used much on this, so we could not renew further. But still, some of the mold makers, at least some arrangements should be made. They should use some software using the viscosity of the compound in deciding the gate size. Today, how many mold makers take the viscosity data while designing mold? In Indian context, it's very less. Very less. So the availability of software is so expensive. So even 1-year license is very expensive, 40 lakhs, 30 lakhs like that. Our Indian mold maker cannot invest such a huge money. So we should find out a way how it can be. They can use a better software to design appropriate gates. That's one issue with the lying between mold makers and mold makers.
There is something called spiral mold. It's a simple mold which can actually if the mold maker has a test machine, he can make a small spiral mold and then he can test all your compounds, how good flow they are. So he can make a judgment. What rather say he should start with. It's possible.
Devan, you have go on, Dr. Graf first.
And to be very basic and go far back on the beginning. If you buy a mold and you get the first drawing, yes, you should have a so-called sign-off procedure. And I put that in place repeatedly in some of the companies, and that means your mold designer in-house should sign off, your production engineer should sign off, and your salesman should sign off. Yes, there's 3 important people on that sign. At least the 4th one is the compounder. And they should be all see themselves in charge that they have a proper design. Yes, so all aspect of production of compound is taken care of by the sign. I think that's a very important measure, and I put that in place with my comrades at this time. That was actually the plant manager or the department manager, because we had so many trouble in addressing the other's fault. Yes, you know, in rubber industry is always the compound's fault, or is the fault of somebody else. It's never yours. So, and when we saw that this type of problem, yes, and there was a very proud engineer as a mold designer, yes, we said that has to end it. Yes, so we have a sign-off procedure, a protocol, and that gives us then the next step. So I think those things we developed in the, I think in the 60s or 70s. Yes, we should practice. They are not bad; they are good. Old things sometimes very good. Yes. So that is the address of people who are working in the plant still, and you as a plant manager or an entrepreneur, yes, you should have those procedures in place. Yes. So
yes, we are getting there, Dr. Graf. We are getting to the 60s.
okay. Yeah, it needs sometimes it needs a little bit of force. I know that. Yes, the human is a little bit static. Yes, and sometimes you need a little bit to push. Okay.
I just have a brief point to make. The selection of tool steel is also extraordinarily critical. I would like to just narrate an experience that we had. We've been going through with mold fouling, as Dr. Graf was mentioning, and it's a really a painful problem to get rid of. So what we thought was maybe we should go with stainless steel mold. So we tried that, and then the results were worse off. And it is only later that we understood that the thermal conductivity of the steel that we are using is of greater significance than whether it is just tool steel, regular tool steel, or it's a stainless steel graded tool steel. So that was a big learning for us. So since then, we typically what is used in the market is everybody uses P20 steel. Now there are a lot of grades and subgrades and manufacturers of P20s. If you choose the right grade, then the consistency of your production is much greater. And the cost component of tool steel in a tool is probably 20 to 30%. So another 10% addition in that 20% or 30% is really not going to hurt you as much as the loss of productivity and all the other issues associated with it. So tool steel selection is something which is of great significance, is what I understood from that.
Absolutely.
If anybody has specific experience on that, I would like them to correct me.
I mean, we had some experience in the past. Of course, depends on the compound. Yeah. I mean, there are some compounds like ACM and FKM. They need special steel, otherwise the mold life will be really compromised. So, yeah.
Right.
And there are so many grades of P20S and P20 nickel, and yeah, you have to be very careful with the selection of the. And also the heat treatment. Yeah. Are you doing plasma nitriding? Are you doing vacuum hardening? What you're doing afterwards? Yeah. That also very important. Yeah.
Now the topic for me is that you have surface energy on steel, and you have a compound with a specific surface energy. So that's, we call that polarity or something like that. Yes. And now you have to think about demolding forces. Yes. But our knowledge is close to zero about that. Yes. We rubber people, we do not understand steel, and the steel people do not understand rubber. That's the situation at the moment. I'm hunting for some sorts of effects. Yes, you see that already when you have high polar rubber. Yes, and the demolding, unloading forces of a part out of the cavity is very different from any other rubber. And sometimes you are confused because, of course, your filler are influencing this polarity, and that has a very large effect on the demolding force. So in all these things, I believe, have to be investigated. We're still waiting for a little bit more systematic investigation of that field, I have to say. I was when I worked about mold fouling. Yes, I was aware that biologists and medicine type of people, they have a much better knowledge on steel surface than any rubber. Yes, and when I'm asking steel people, can you tell me something about that? They think totally different. They think in machining. They think in working on by grinding, things like that. What do you do? Yes, with a piece of steel, drilling. So, and this world are pretty much apart. I can only say that. So I'm waiting for a brilliant institute, maybe somewhere in the world, if not in India, yes, to start at least some sort of projects. What is the effect of those parameters on, yeah, for example, on breaking the parts during demolding? Because for if you go to automatization, yes, it is more and more important.
Yeah, very good.
Deven, I want to ask you, what is, you have like Maplan intelligence, some kind of program, right? Would you like to talk about it?
I mean, same what Dr. Graf said, it's too much information if you want to use it. But we basically, basically the machine monitors, okay, Maplan, okay. So we talked about OPEX and CAPEX. So let's see what, how Maplan can help. I mean, Maplan machines, injection unit has only 5 or 10 gram rubber which stays back. We don't have nozzle bodies, yeah. So it's very easy to change compounds. There's no wastage. You don't need to purge. There is no rubber to purge. So that helps a lot. Maplan cool drive is a very big thing. I mean, this servo drive, it saves almost 40 to 60% of the electrical power, and we have so many test comparisons. Right from O-rings to big thick parts, everywhere there is a saving. So this has to be done. This is the future. I mean, Maplan, last year we sold 95% machines, including China. China, we don't make normal hydraulic machines anymore. We stopped it. Maplan China only produces cool drive machines because the Chinese market only accepts cool drive machines. They don't want to waste any more electrical power. This is a big thing what we could help industry with. Cold runner blocks, of course, there are so many manufacturers, so it is always better to have a local mold supplier blocks for the after sale support. But Maplan Auto Cell is when we talk about automation, Maplan has a unique solution that Maplan control system also controls other automation devices like robots, like visual inspection, laser marking. You don't have to go to that particular machine and play with their control system. We have a communication protocol where all those devices can be controlled through Maplan control system, which is very unique. So you can start the complete sale standing in front of only one operator panel. You don't need to go to laser marking, start that, go to visual inspection, start that. No, everything can be done through one control system, which helps when you're talking about auto cells. Yeah? Map remote is, of course, our machines can be accessed. I can access machines globally, and we can do after sale service online without actually going to the place. That really helped us a lot during the COVID situation. This feature is available for many years, but we did not realize the importance. But we realized it during the COVID, where really it was not possible to go to customer places, and it really helped. Even we realize how important it is, not only customers. Earlier it was only about sales talk, but now we know it is really important. It helps, and it was very good. And the spare part packages. Normally we have this 3 levels of spare part packages, which we offer with the machine, so that customers normally have the more wear and tear spare parts always available with them, so that it can be changed. They can have access to. They don't have to wait for us to supply them small spare parts like oil filters and small seals and all those things. So this is how we help to reduce OPEX. That's I just wanted to give some bold points. So yeah.
Deven, just a quick question.
Yeah.
This power saving that you were talking about, is it on the heating load as well, or it's only on the?
This is mainly the electrical power. So if you consider the total connected load, it is about 25%. I mean, we have test reports that the total, including heating, it is about 25%. How we save in heating is, Maplan, even heating plates are insulated from all the sides. And we have the special PIDs, PID temperature controls. That also saves a bit. And we have this we have a software which we call it energy monitoring, so that we can also start the heating sequence of a press, so that you don't waste power. Like plasticizing cylinder, we will start heating first, then we start heating the pot, because we know pot takes much less heating time. So we don't start everything at one time. Yeah? We go step by step, so that we know when the mold is going to be hot, so that just half an hour before that we start heating the injection unit. Also that we start heating in parts, so that there is no extra heat wasted, energy wasted. So this is also one of the point. Yeah, I mean, when at least for injection molding, you should not take frequent breaks. I mean, there are some customers who run only couple of shifts and then stop. Every morning they heat, every evening they cool down. That should not be the case. You just run 24/7. Maybe you can run for 3 days and then stop the machine for that week. So frequent breaks, if you can avoid, also it saves a lot of cost. Because rubber machines, you need to heat again in the morning, and a couple of shots are then not good. So try to run it as long as possible. You finish your order, then you stop. It is better to carry some inventory rather than starting and stopping big machine every day. So that's one more point I missed, I would say.
Karthik, I have a question for you.
Yes.
You have a mixing room also. You do mixing. So which is the painful, the mixing area or the molding area?
Definitely, mixing area is the painful area, because maintaining 5S is an eternal challenge, and all the equipments have to be in top shape, because that impacts the molding shop. That sets the tone for the entire factory. So how well your factory runs depends on how good your mix is. So it is literally as simple as that. So the more energies we invest in fine-tuning that process, one of my seniors, he used to tell me that molding is a skill, but mixing is an art. So the more you invest in mixing, and tooling is also an art. So the more you work there, automatically all the other so-called issues, all the other knots untie themselves, and there are very few knots left to untie. So most definitely mixing is the area where everybody should be concentrating far more than what they do.
Absolutely. Yeah. I mean, even if you have the best molding machine, if you have bad compound and bad mold, it is not going to help. It is going to produce scrap. It can produce much faster scrap than any other machine. If you have a good machine. So, yeah.
EP, what is your experience with the mixing room? What kind of waste is happening in the people who has both molding and mixing?
Especially the mixing, the people just mixing is not just an activity. Many times the injection moldings especially requires a very consistent rheology, which at times it is missed out. And the people we have to give feedback to the mixing operator. Most of them, the feedback will not reach them. So they make a wider tolerance and they want to pass the compound. So they make a wider rheo tolerance and pass the compound. That should not be the objective of rheology, is to control and then give feedback. So the industry has to give feedback to the operators and understand mutually why it has happened and etc. Because many of the time, some of the very sensitive ingredients are added in the open mill. For example, some peroxides and some liquid accelerators are added. So we have to ensure that it's getting into the compositions. Sometimes they miss it slightly. So that you have to give a feedback. I feel more on the feedback mechanism. Once you give feedback to the mixing department, obviously they will get enthusiasm on correcting, and they themselves will come and see the rheology, whether everything is falling within the line or not. So I strongly feel no mixer will want to produce a defective compound. We have to give a feedback to them. So because obviously the man used to do some experimenting with himself, how to reduce the time, how to increase the speed, etc., etc. So we have to give a feedback. Yes, you have done something, would have done wrong. So you see the rheograph variation. So the feedback is the best way to improve the compound mixing. That's what I think.
In the same context, I would like to add one more point. Like the new Maplan control systems, they have a feature where when you inject and when you plasticize, this is that whole curve is traced, and you can actually define the tolerances. That okay, I want within 5% of this curve. So if every shot it will be monitored, and if there is any change in the viscosity or in the rheology, that will be monitored, and then error message will be given that okay, this shot the compound did not follow the exact curve. It went 6% or 7% out of the limit, and that can be then traced back, and then the feedback can be given to the mixing department that okay, this strip, particularly this batch, is slightly harder or softer or whatever it is. Yeah? But now the machine can trace it now, and this is not only about normally in the past we used to monitor only maximum pressure, processing time. Now the whole curve is traced shot to shot, every small thing. After pressure, injection phases, after pressure, everything is monitored, and then those graphs are traced shot after shot. So this is now you have a complete control over the rheology. At least the machine will check that the compound was within the range. Yeah, and if it's not, you will get error messages. So yeah.
I think this is the truly standout feature.
Yeah,
All the features that we've discussed
nice
today,
feature.
this is the truly standout.
It's a nice feature, yes. I was very surprised to find it, and it works. It's not only I've seen it work. It really works.
As an engineer, this is something which I really
Very nice. And one more feature which I like about Maplan system is you can have your own messages for the operators. You can say after 5 cycles, the screen will show that okay, spray mold release or clean this or check that or whatever. Yeah. So you can have your custom even video messages. You can also put videos to show the operator how to spray or how to check the part, which is what is air trapping, what is not air trapping, what is allowed, everything you can do. You can have PDF, you can have videos, you can have audios, and all that can be integrated in the auto cycle. And you can define that, okay, after 20 shots, show this, after 5 shots, show this. It has become, yeah, machine is becoming smarter and operators are becoming, more dumb.
You'll be happy to know that they've got this feature added in the latest Desma that we got.
Okay,
The spray cycle. That is, it'll prompt. We can custom define the spray cycle count, and it will prompt. It will not allow the next auto.
Okay, yeah. So the machines have to become smarter because operators are getting more and more dumb. That's what we say in US. Anyway.
Okay, guys, it's really fun and it's really, informative, enjoyable. Before we end this session, I'd like to ask you to give final remarks. Okay, EP, I'd like to go first. Yeah, what some kind of key points that the industry should aware of it. 1 or 2 points, and as a remark for you. Yeah.
As an industry, as it was mentioned, it is the machine selection which is very important in the initial start of any manufacturing operation, and we must see that the features are fulfilling the requirements. And when designing the mold, one has to make sure that it is designed optimally with the proper design. And apart from that, we have to look into the certain non-value added operations, and implementation of preformers will minimize the cost, and also the various aspects such as how to optimize the cavity. The more the cavity is not more profitable. In cases it is required that we have to have a lesser cavities, that also will give a minimum defects. So we can't take a simple arithmetic rule for everything. We have to get into the individual parts or part complicacy, deciding about the number of cavities. So it is not the cost, which is just only materials. In the process, how do we waste the material, how the defects are produced, those also are add to the cost of the entire manufacturing cost. So in this process, the very valid point is we have to look into the totality in terms of the process cycle and the kind of inspection and inspection cost. And when there is a huge pressure or year-to-year cost reduction demanded by OEMs, as Mr. Karthik was mentioning, there is always a mission inside the machine. I use this word, and we can always put our mind inside the process, and we can work upon continuously to do some cost optimization to compete in the current industrial scenario. This is what my personal view. Okay.
Thank you, Dr. Graf. Thank you very much, Dr. Graf. Oh, please tell that. Please read the book. Okay. Show one more time the book.
Okay.
Yeah, guys, we want to reduce that book and also the cost reduction. Okay.
Yeah. In general, it's all about knowledge, I think, and of course correlation and cross correlation between mixing room and compound design, mixing room and process like molding. And we explained that in the past, and in extrusion, which is a little bit more sensitive than molding. And all of this needs to be not guessed around and estimated. We need to have knowledge about the correlation in terms of either statistic regression function or in terms of strict rules which are proven to us. Yes, we need also to see that in a rubber industry there's a lot of beliefs about effects and causes, and that has to be end, because I think we are with that knowledge today that we can leave that behind us. And another point I like to make is we have a long history in rubber. Yes, and sometimes I believe the people cannot read for a certain reason, I don't know. Yes, we have a lot of experimentation in the literature. So people can also, before they do something, maybe go in a library or on their computer to Google or whatever and make a little bit an investigation before they say something. Yes, excuse me for that. I'm a little bit, no, not cynic, but it is sometimes it is frustrating. And still, the chemists should have learned in their education. You first read and then you experiment. Yes, sometimes you survive that way. That's also true. So the point is, yes, we need not experience, we need knowledge.
Okay. Thank you,
Well,
Dr. Graf. Devin, yeah.
Yeah, I mean, cost reduction is a very vast topic, and I think we need a more broader outlook. We need to check OPEX, CAPEX, everything, do a lot of analysis before we do anything. And more you do at the planning stage, it will help you in actual production. Yeah, and there has to be a collaborative, effort between the actual molder, machine supplier, and the mold supplier, and that will really help to control the cost. So they all three have to be part of the team, and they have to brainstorm it before you actually do it. Yeah. So yeah.
So
Thank you, Devin. Karthik, please.
Yes. So all I would like to just share with my fellow entrepreneurs is that the topmost award for quality in production is probably the Deming Medal, and what it says on the Deming Medal is it is awarded for the excellence in use of statistical tools for process control, or I'm just paraphrasing. So what I would like to point out here is please collect data. That is very, very important. And the most important data that you should be collecting and monitoring is the net value added on a daily or monthly basis, and the operating margin on a daily or monthly basis, and the net profits on a daily or monthly basis. And that will unfold into all the various initiatives that we were talking about all this while. So please collect that data and then use that data. That's the only panacea to all the problems that we have.
Super, guys. It's really, very interesting, very useful discussion. I thank you all, for joining this session. EP, Dr. Hans, Devin, Karthik. I think we covered is the word 360 degrees. I think we really covered all aspects of it, and I'm really thankful to all of you for joining the session. I'd like to have more discussions like this in the future, and relevant to the industry. As you say, knowledge. TechNob is one platform, try to provide, even with not up to it, but we're still trying our best to meeting the requirements of the rubber industry. So once again, and sincere thanks to you. Thank you very much, all of you. Appreciate the inspiration.
Thank you.
Thank you. Thank you.
Thank you.
I'm happy
Guys,
Easter.
Bye-bye.
Easter.
Bye.
All the best. Stay safe, everybody. Yeah.
Thank you, guys. That's the end of the panel discussion on the cost reduction in molded rubber products and manufacturing. I'm hoping that you really find this useful. You hear 150, I don't know, 150 or 160 years of experience. People talk together and various issues about the what is possible and what kind of things you can do to reduce your cost. EP, Dr. Graf, Devin, Karthik put together a nice discussion for us today, and please check this whole session if you'd like to watch again, and on YouTube. It will be available next 24 hours time. Check it out. Okay. If you need any information from me or any assistance from me, you can reach out to me. Okay, I think most of you have my contacts. Thank you once again for any questions you have. Okay, I am hoping to see you in the next episode. Okay, on Rubber Industry News Hour. Thank you all. Bye bye for now. Thank you, Devan. Excellent. Dr. Graf, thanks a lot. Yeah.